So today in class, we talked a little bit about ratios and probability. I'd like to discuss that further in case what we did in class wasn't enough to help remind you of probability, because it's something that you did in algebra. This was supposed to be a small minor review. So recall that a ratio is a comparison of two quantities. So you can write your ratio with the colon as the fraction, or we say the phrase A to B, or cloudy to no cloudy days, as we were talking about in class. So each ratio has a numeric or number value. You can express it as a fraction or as a decimal. So the example that they're showing you here, a normal deck of cards has 52 playing cards in it, and 13 of those cards have hearts. So if you wanted to compare the number of hearts to the total number of playing cards, you would write number of hearts in the top of the fraction, which I always like to say is the thing that you want, what you're focusing on. Then the bottom number, or total number of cards, is just that. It's your total of outcomes, cards, dice rolls, colors in a spinner, number of times that you move a shape. Those are all the things that the totals go on the bottom. Then we place our numbers in. We reduce. This is a reducing step. So each top and bottom was divided by 13. And then if you put 1/4 into your calculator and divide 1 by 4, you get 0.25. Now recall that when we have a decimal and we move the decimal place over 2 places, we can say that number as a percent. Now some of us will already know that 1 divided by 4 is 0.25, but if you are unsure of what the percentage comparison is, just plug it into your calculator and divide. So now probability is the measure of the likelihood that an event will happen. Mostly we usually see probability expressed in the percentage form, like the weatherman says 40% chance of rain for today. That's the probability. He doesn't really know what's going to happen, so he's taking a gamble, and as we all know, he or she is not always correct. So we can write the probability of an event happening in our ratio. So what we say is that the probability of something happening, our event, is equal to the number of desired outcomes. So back up top was the same thing. Number of what we want, number of things desired that we want to happen, non-cloudy days versus cloudy days, over the total possible outcomes, over everything that can happen. So this problem, they talk about a standard die or a dice. Die is plural for dice. So this P of 5, the probability of rolling a 5 means that how many different ways can you roll a 5 on a dice? Well, since there is only one side with the number 5, but there's 6 total numbers on that dice, so there's 6 things you can get, only one of them you want, so therefore you place a 1 over 6, and when you divide that you get 0.16, which is approximately 16.7% when you plug it in your calculator, which means you have 16.7% chance of rolling a 5 every time you roll a dice.